Okay, to row reduce this bonus question number one, the first thing that we have to do is we have to take this system of three equations and three variables, and we have to write it as an augmented matrix. And what that augmented matrix looks like, or you just simply take the coefficients from each line here, and you write them in corresponding rows and columns. So we have 2, 3, -1, and 15, 4, -3, -1, 19, 1, -3, 3, -4. Okay, so here's our augmented matrix. Now, to row reduce this, our whole objective is to get this matrix, this augmented matrix, down to a reduced row echelon form of this matrix, which means we have a 3 by 3 identity matrix. Okay, I guess kind of augmented here with our solutions, whatever these numbers might be. Okay, and the way that we do that is by manipulating these rows. We can move them, interchange 1 with 2 is the first thing I'm going to do. Multiply, add, subtract, divide if you prefer. But just keep in mind that these are equations, and the properties of equality hold true, and all the techniques we use for solving systems apply here. So what we're looking for, and where I always start, is I always start in this column and I work my way down. Once I've taken care of this column top to bottom, I can really go anywhere from here. But the first thing I want to do is I want to get a 1 in row 1, column 1. So I'm going to take a look at this matrix, and the first thing I'm going to do is I'm just going to move that equation to the top. And people say you can just move equations. Well, you're not changing the value or anything. You're just rearranging the order. So yes, you can. From there, I'm just going to move these rows down. Again, I could just move this row beginning with 2 down to the bottom. But I'm just going to move all these down. Okay, and so now I have to worry about my zeros. So that's good. I have to worry about my 0 here and here. Now again, just as we solved a system with 3 variables and 3 equations, our whole objective was to take a combination of any 2 equations and eliminate the same variable twice. With that in mind, what I'm going to do is I'm going to take a combination of row 1 and row 2, and then row 2 and row 3 to cancel out the x. Because remember, if you look at this column is x, this is y, this is z. I guess this would be our constant. This is equation 1, equation 2, and equation 3. So I'm going to take a combination here. I've switched 3 with 1, but I'm going to take a combination of what's now equation 1 and 2. And in order to cancel this out, what I'm going to need to do is multiply this by -2. So -2 times this row gives me -2, +6, -6, +8. And then I have row 2, which is 2, 3, -1, and 15. And when I add these, 0, 9, -7, 23. Okay, now I'm going to take a combination of rows, the new rows 2 and 3, but I'm going to need to multiply the top row by -2, which is going to give me a -4, -6, 2, and -30, and I'm going to add that to 3. Different combinations, okay. And what I'm going to end up with when I add these is 0, -9, 1, -11. So now from here, again, I've already taken care of the 1, so that 1 has got to stay there. I can put these in any order I want. I could even change all the signs by multiplying through by -1, but as I see it, I'll just leave it here. Okay, check and check. Now from here, I can really go any direction. Just looking at this, I know I want a 0 in this place right here. And I can see that I can do that pretty easily by just adding these 2 together. And if I add these 2 equations together, I guess the new 2 and 3, which again were just found by manipulating the original equations. When I add these together, I have 0, 0, -6, and 12. So again, I've accomplished this purpose of getting a 0 here, but if I look at this, and this is the thing that you should always do when you get down here to really our z and then our constant, think of this, this is actually -6z equals 12. we want a 1 here. We want 1z. So if we divide both sides by -6, z is equal to a -2. Now again, we don't need to write out this step if you understand it. From here, this line becomes 0, 0, 1, -2. So we've gotten a 1 here in our constant. So we're actually done with our bottom row. So I'm going to go ahead and I'm going to insert that. Okay, 1, -2. Now, as you move through this, you can really use any combination as long as you're not using, the same equation or same line twice. Again, trying to plug it into itself is going to give you an infinite number of solutions. So as long as you don't use that, you can use any of these. I can now use this to cancel out, or to reduce this down to 1, or cancel that out to make it 0. So, as I look at this, I guess from here, okay, I have this. Some people might say, okay, I need to get a 0 or a 1 here, which is not really a bad idea. But remember, I just said that we could use this particular line right here. And the fact that this is a 1, canceling out the -7 here, or canceling out the 1 here, would be a very, very easy thing to do. And you might say, wait a minute, that just became this. No, a combination of these two became this. So I can still use this equation, or I could use the one above it. The hard thing about teaching this particular technique is there's no set pattern, and it works out differently depending on what the numbers are and how the equations, seem to work out. But what I'm going to do is I'm going to take this equation, so I'm going to come back here, and I'm going to take this equation, and I'm going to multiply this by -1. Multiplying by -1 doesn't change that value or that value. It makes this -1 and this a +2. When I add these together, I have 0, -9, 0, and -9. Now, if you see what that allowed me to do, getting rid of that 0 was easier than getting rid of that 9 because I have to deal with fractions. So from this step, again, this is 0. This is actually a -9. Y equals a -9. So to solve for y, I would divide by -9 as I did to solve for z. So y is going to be equal to a +1, which again, this line would lead us to 0, 1, 0, 1, dividing through by -9. So I now have this line. Check, 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 and check. I've now solved for z and I've solved for y. The last thing I have to do is use any combination of equations to get rid of this -3, make it 0, and make this 0. Now, as I see it, using these is going to be the easiest way to do this. Just in my opinion, it's the fewest amount of multiplication. So what I'm going to do is I'm going to come back up here, and I'm going to take 1, -3, 3, -4, and I'm going to use this line right here. So what I'm going to need to do is I'm going to multiply that by 3. So I have 0, 3, 0, 3. So I want to add those. I'm left with 1, 0, which was what I was trying to accomplish, 3, -1. I don't need to write that down. That's my new equation. It would go right here, but I don't want to write it down until I've gotten rid of this 3. And what I'm going to do is I'm going to take this equation right here, that line right there, and I'm going to multiply by a -3 to make this negative, which would make this a +6. So now when I add these, 1, 0, 0, 5. So now I've accomplished what I set out to accomplish. I took this system, wrote it as an augmented matrix, and then took that augmented matrix and was able to write it in reduced row echelon form. And again, the whole purpose of this, remember, this column was x, this column was y, this column was z, and this was our constant. What we have here is 1x plus 0y plus 0z equals 5. Here, 0x plus 1y plus 0z equals 1. And here, 0x plus 0y plus 1z is equal to a -2. So we have the order triple, okay, which is a point in 3 dimensions, where these three equations, which represent planes, intersect. And that's our solution, 5, 1, -2, using row reduction and taking an augmented matrix and writing it in reduced row echelon form. Hopefully that helps. This is a difficult process, takes a lot of practice. There's really no set way of doing it. Just remember, pretty much everything goes. Just don't use the exact same equation and try and plug it in or eliminate it from itself, because you're going to end up with what appears to be an infinite number of solutions, which in this case is not true. So hopefully that helps you with the bonus.